Translating a graph means to shift the graph, moving all the points together. Now we can translate vertically and/or horizontally. In this tutorial, we'll look at how to shift a graph vertically, up or down. Again, let's relate back to our linear relationship knowledge. In slope-intercept form, we can easily identify the y-intercept, or the b, at the end of the equation, the constant. So let's consider the base linear equation, y equals x. And in this case, with no b being shown, well, we know that the b is 0. And it looks like this. When x is 0, y is 0. It passes through the origin. So what happens if the b becomes 3? Well, now, when x is 0, y is 0 plus 3 is 3. So we've shifted the graph up by 3. And what if the b is negative? If b is negative 4, say, well, now, when x is 0, y is 0 minus 4 equals negative 4. So we've shifted the graph down by 4. So relating this to quadratics is super easy. Starting with the base quadratic equation, that is, y equals x squared, when x is 0, y is 0, again it passes through the origin. Then the constant at the end is the same as our b in the linear relationship, in that it shifts the graph vertically. So what happens if the constant is 3? Well, now when x is 0, y equals 0 squared, or 0, plus 3 is 3. So we've shifted the graph up by 3. And if the constant is negative 4, well, when x is 0, y is 0 squared, or 0, minus 4 is negative 4. So again, shifted the graph down by 4. So, vertical translations in quadratic relationships is quite intuitive, and it relates nicely to the previous knowledge about linear relationships. And as we look for patterns in quadratic graphs, this is another great clue. Where does the graph sit vertically?